Hello, algebra students. Today we're beginning our new unit. This is called Unit 7, Part 2. We are going to be focusing on solving quadratic functions. So you can kind of see, everything we're doing here, we're solving with different methods. The last unit we focused on graphing quadratic functions. So we're going to learn how to figure out the values of x. So let's go to day 1. So day 1, we are focused on solving by graphing a quadratic and a method by using square roots. So I am beginning here with a little bit of vocabulary that this will help set up some of the meaning behind this. So the first blank I'd like you to fill in would be the word solutions. Oops, let me adjust that. Oh gosh, sorry. Solutions. Okay, so the solutions of a quadratic function are the x-intercepts. Next blank would be x-intercepts. The solutions of a quadratic function are the x-intercepts, which in parentheses is where the graph crosses the x-axis. Also, they are sometimes called roots or zeros. Okay, so if you think about an x-intercept here, if I, had a dot right here and right here, let's say I had this parabola that did this. So when the dot is on the x-axis, it is an ordered pair. Let's say that's at 1. It would be at the x-intercept comma 0. So then, the zeros here come from the fact that the y value is always 0. So that's why sometimes it's called zeros. Okay, moving on. For quadratic equations, there can be 0, 1, or 2 real solutions. 0, 1, or 2 real solutions. All right, and so we will see how there can be these different variety of solutions when we actually look at the graph. All right, so our goal here is to find a solution, find the value of x. Graphically, we're finding the x-intercepts. And there could be 1 answer, 2 answers, or 3 real solutions. All right, finding solutions, 2 methods. Number 1 is graphing. Okay, so if we graph the function, we can visually look at, well, where is it crossing the x-axis? Second, we're going to solve it algebraically. So just like you solve a linear equation and get x all by itself, it's the same here. All right, let's start with graphical approach here. What are the solutions of the quadratic functions? So we are looking at where it's crossing the x-axis. So right here and right here. And so you can see, I'll kind of rewrite this. The left solution is -2. The dot on the right is at +2. So here's a case where it crosses the x-axis twice. Therefore, there are 2 solutions. Okay, so I'm just going to add here underneath it 2 solutions. Okay. Next, see how the vertex is right there on the origin. So it's only crossing the x-axis in one place. So here's your x-axis you are focusing on. So I would have 1 solution, and that solution is the number 0. All right. So this is an example here of when we have 1 solution. And then finally, the third one over here, notice it doesn't even touch the x-axis. So we would call this a no solution. Now, when you get to Algebra 2, there is a solution, but it's not considered a real number. You will learn about a whole new subset of numbers called imaginary numbers. So for Algebra 1, though, we are going to say there's no solution. So I'm going to write here 0 solutions. Okay, so if you can get it on a graph and you can visually see if it's crossing at 1, 2, -1, -2, this is a way to see it. Now, sometimes it doesn't cross at a perfect integer. Okay, sometimes it crosses at 1.754, and I can't tell by looking at a graph. So we need another method in order to find the solutions. So now let's bring in how to algebraically solve this. All right, so we are asked to solve for x. So what I would begin is we are going to start exactly like we do with linear. All right, so our goal over here, I'm just going to make a little note. We are going to, gosh, my screen keeps moving. Isolate x. All right, so in order to isolate x, step one is I need to get 98, the negative 98 on the other side here. So I am going to have to add it over to the other side. So that leaves me with 2x squared equals 0 plus 98 is 98. Now, x squared is not isolated yet, all right? I need to get rid of the 2 in front. And so since it's being multiplied, I need to do the opposite. So I'm going to divide by 2. Now I have x squared equals 49. So if you think about this, you're looking for a number that when you take it to the second power, it equals 49. So that number would be 7 because 7 times 7 is 49. Now, the function we use, the opposite, if we took 49 and we took the square root of it, we would get 7. So the opposite of raising to the second power is taking the square root of a number. Okay, and on your calculator, the square root key is usually right above the x squared key with the, you have to hit the second function. So what I'm going to do here, I'm going to say, okay, I need to get x all by itself. So in order to do that, I have to take the square root of both sides. So I get x equals 7. Now there's a catch here. There's actually 2 numbers. Because if I take 7 and raise it to the second, I get 49. But if I take negative 7, I also get 49 when I multiply it by itself. So we can sometimes write it like I have here, or sometimes we write it with this symbol, a positive sign and a negative sign under it, and then the number 7. So I would say that when I read that, I would say plus or minus 7. All right, so both of these are accurate. You'll see it probably plus or minus 7, but you can also see it written out twice, x equals 7 and x equals negative 7. All right, so the key element here is when you are solving an equation with x squared, we have to ultimately take the square root of both sides once we have x squared isolated. So here's an example of 2 solutions. Okay, number 3, you need to isolate t squared. So you're going to add over the 25 here. And so I end up with t squared equals positive 25. So remember, I'm saying, all right, I need to do the opposite of the second power. So you're going to come through here and take the square root. So t is going to equal both 5 and negative 5. So I'm going to write that either as plus or minus 5 on paper, or I could say t equals 5 and t equals negative 5. I'll kind of write them both out, but I want you to get used to seeing that notation of plus or minus. All right, let's keep going. So I would actually like you to try number 4 on your own. So if you would pause right here, work out number 4, and then come back to the video. Okay, step 1 is you need to take away the 12 from both sides. So that leaves me with 3n squared equals 0. Now I'm going back and saying n squared is not isolated yet. Divide off your 3. So 3 divided by 3 is 1. So now I have n squared equals 0 because 0 divided by 3 is 0. And now I'm going to say, okay, I need to take the square root of both sides. Well, I get n equals 0. Now, I don't have a plus or minus here because there's no such thing as positive or negative 0. So here's an example of a single solution in our quadratic. Okay, number 5. Step 1 is the same. Move the single number to the other side. All right, so I have 1/2 g squared equals negative 3. So get 1/2 by itself. So you could do one of 2 things. You could divide off 1/2, okay? Or, let me rewrite the problem. if you take 1/2 g squared equals -3, my goal is to get a 1 in front of g squared. So if I take any fraction and multiply it by its reciprocal, I get 1. So I could come through here and multiply by the reciprocal. And feel free to calculate it on your calculator. Do 2 times 1/2 and you get 1. Either method will get us to this point. Oh, not t, this time it's g. G squared equals -6. Okay, either way. So I am coming through here again. I need to take the square root. So if you take the square root of -6, your calculator should give you some sort of error message. There is no number that I can multiply by itself and create a negative number, because 2 negatives multiplied make a positive, 2 positives multiplied also make a positive. All right, so there is no real solution here. No real solution. Okay, and so I'm going to put the word real in there this time because there's actually an imaginary solution, but you guys won't study that till Algebra 2. Okay, I want you to wrap this up. I'd like you to come back when you have 6 and 7 completed. Okay, I did not give you any specific directions. We're getting a decimal here. So let's go ahead and round it to 2 decimal places. So I took the square root of 45 and I'm gonna say it's plus or minus because you always have 2 answers, about 6.71. Okay, so I will give you better directions, but you can write it this way or you can separate it out. -6.71, positive 6.71. Okay? And then on the last one, let's see. So I am either ready to divide off a third or keep your, let's go, I'm just going to rewrite the problem. Or if you multiply by the reciprocal, so see how I'm just doing 32 times 3, or I'm doing 32 divided by a third, which ultimately will just be 32 times 3. So I'm getting x squared equals 96. And then I am now ready to take the square root of both sides. And I'm getting another decimal. So let's just go ahead and continue to round to 2 spots. So plus or minus 9 point, okay, this is 9.79. So the 9 will actually bump my 7 up to an 8, okay? Or I'll just continue to write it out twice. Negative 9.8, positive 9.8. All right, so I'll go ahead and put a box around either. Okay, that wraps up solving algebraically. And also if you have a graphical approach, you can see those solutions. Okay, if you have any questions, feel free to email me or ask in class.